Hi class. Today I'm going to cover the first part of 10A, and it'll probably be 2 sessions, okay? But before that, I just want to compliment you on your submissions for your test. I was quite impressed that everyone made such an effort to make it easy for me. I really appreciate that. I'm in the middle of grading them, and I've also got the projects to grade, so it'll be a while before you get your grades. And I'll send it out with a note, of course. So are you ready? Oh, and one other thing. On your homework submissions, where I ask you questions, I think we all agree that most of the class does not like online learning. And it would not be my first choice either, because the reason I teach is I like the interaction in person with my students in my office and in my classrooms and on campus and all. So you guys are troopers. We'll just try and weather through it. You can always send me questions via email or text or phone call, and some of you have, but more of you can or should. Okay, ready for lecture? First of all, I want you to write this down. In section 10A, you have the assigned problems up through 45, and that's what your quiz 10, which is Wednesday, will be on. And then this is your last homework assignment. The rest of 10A and the 10Bs that I've cited here, I've cut out some problems that are just too hard to explain without you in front of me. And that will be your quiz 11. Okay, for the 10A section here, these formulas start on page 585, and I will do those with you tomorrow or Wednesday or Thursday, I'm not sure. Okay, the first thing I want to do is your beginning problems on 10A is I want to change the degree angle to the fraction of the circle that it is cutting off. That's this part. I want to know what fraction that is of the circle. Now, the authors use the word subtend, and subtend just means cut. Okay, so to go from the degrees to a fraction, you divide by 360. So I have 30 degrees, and I'm going to divide it by 360, okay? I cut those, because they don't make any difference, and I get 3 divided by 36, which is 1/12. And that's the answer, okay? That's pretty easy. Okay, but sometimes you want to go from a fraction back to a degrees, okay? So this time we are going to subtend 1/5 of the circle. And this time you multiply by 360. So it's 1/5 times 360. Okay? So I think that you should be canceling. 5 goes into 5 once. 360 goes in, is divided by 572. This is 72 degrees. Of course, you can always use your calculator. Okay? But, it goes 72 or 72.5, something like that. These are pretty reasonable numbers, okay? These are not hard problems. It's just knowing when to divide, degrees divide, or fractions multiply. Okay? Okay, the next thing we're going to do is talk about circles. Just plain circles, like a lifesaver or a donut or a rubber band, nothing inside, okay? So one thing that's stressed in this particular unit is units, okay? This is the circumference, or the perimeter is a single unit, like inches or feet or miles or centimeters, okay? An area is always, always, always squared. You might see this in your science classes. So, but like square inches, or inches squared, or inches cubed, or feet squared. I'm sorry, I didn't mean to say cubed. Feet squared, miles squared, centimeters squared, liters squared. Volume is a three-dimensional figure, and we'll be covering that on the next lecture, the next day's lecture, 10B's lecture. Volume is cubic, like centimeters cubed or feet cubed or acres cubed, something like that, okay? So I'm going to be attaching units to all of the questions, and I'm going to grade units on the tests and on the quiz and final. Okay, so for instance, the circumference is 2 pi r. The circumference is the area around the circle. Like from here, you're walking in a circle, okay? Now I've noted that this particular circle has a radius of 4 inches. So, do you know what the diameter is? Okay. Some people get confused, but the diameter is this 4 plus this 4, so it's 8 inches. Okay? If you get, none of our formulas refer to diameters, but you could be given a diameter and they're giving it to you, or I'm giving it to you, to see if you know to cut it in half to get the radius. Okay? Now over here I've written the 2 formulas. Okay? Now you have a pi button on your calculator, and on the bigger calculator it is on top of the power button right here, and it's blue, so you have to go second pi. But I don't want you to use that button, okay? I want you to leave pi alone. You see, I have it in red. So that means I don't want you to touch it until you put it into the answer. And I'll tell you why in a minute. Okay, so for this one, what is the circumference of the circle? Well, I go to pi, which I'm not going to touch, and r is 4. So in this case, all I'm going to do is multiply the numbers. 2 times 4 is 8 pi. Circumference is a singular unit, inches, period. So it's kind of like if that's a rubber band, I can cut it and open it up, and it will be 8 pi inches long. Now, why do I want the pi in my answer? Let me put it in red for you. Why do I want that? Because when you take your final exam, most of it's going to be multiple choice. And if I put a 3 in there, you're going to say 24. If I put 3.1, you're going to say 24.8. And in a multiple choice, if you don't see what you got, you're going to think it's wrong, okay? Or you won't know where to round off. And don't say that I can tell you where to round off, because no one pays attention to those directions anyway, as you well know. I've mentioned this many times. So for all these answers with pi, I'm going to leave pi in the answer. Now if you say, well then how do I know if my answer's right or wrong? Well then go, this is the answer I want. Go 8 and then your pi key on your calculator, or you can just enter, I think what they use, 3.14. You could go 8 times 3.14, and that should be the book answer, okay? But I want the pi. All right, so here I'm going to find the area. The area is the inside, okay? Everything inside, like a pizza or a cookie, okay? It's the inside. So it's pi times r squared. And again, you only do the black numbers. 4 squared is 16. Then bring down your pi, and there's your answer. Area is always a squared relation. So in this case, it would be inches squared. Okay? There's your answer for area. There's your answer for circumference. Okay? Okay, you ready for this one? This is a square. It has to be a perfect square, and you know that squares have right angles for all 4, and all the sides must be the same in order to be a square. That's from your high school geometry, okay? So we call this a side. The formula for the perimeter, this is like the block you live on. You start here and you walk, 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 walk. That's 4 sides. So here it is. 4 times 2 centimeters is 8 centimeters. And again, this is a perimeter, so it's a single unit. Here you have side squared for the area. This side times this side. Well, this is 2. So, or you don't even need that. You could say 2 squared for the area, which is 4, and area is a squared relation, centimeters squared. Okay? And that's it for a square. Not hard at all. Okay? And a square, of course, is empty for the perimeter, but filled in for the area. Okay? Next, we have a rectangle. Now, they call it length and width. Okay? But when we turn it into a solid, it's going to have base and height. So don't get hung up on the variable names, right? So for the perimeter, it's this side and this side. That's 2 of those, 2L. Plus this side and this side, that's 2W. Not hard. Also in a rectangle, all the corners are right angles, and the opposite sides are the same. Okay? So, to find the perimeter of that particular rectangle, we go 2 times 6 plus 2 times 4. 2 times 6 is 12. 2 times 4 is 8. 12 and 8 is, can I fit it in? 20 feet, singular unit. Here, this is the easiest formula next to the square. Length times width. 6 times 4. 4 times 6, 6 times 4. 24. This is an area. It's feet squared. And that's it for a rectangle. How simple is that?